Math 1314, Tyler Junior College, Section 2.2, more on functions and their graphs. Example of increasing, decreasing, and constant. In the previous video, we defined what it meant for a function to be increasing, decreasing, and constant. We defined it both rigorously from an algebraic perspective and a little bit more loosely from a geometric or a visual perspective. In order to answer this question, we really don't need to rely on the algebraic definition. The algebraic definition is more of a primer for some things that would happen in a calculus class. So for those of you heading towards calculus, you've been warned. Consider the graph of y equals f of x below. We've got this funky looking graph that's made up of pieces of multiple graphs. We've got a horizontal line segment on the left, we've got a parabola in the middle, and then suddenly the parabola takes a sharp turn and makes a line, geometrically a ray, going down towards, all the way down to negative infinity in the y direction. In the x direction, it's going to positive infinity. And our three questions, naturally, are A, on what interval or intervals is f of x increasing? B, on what interval or intervals is f of x decreasing? And C, on what interval or intervals is f of x constant? The hardest part about this is not identifying the portions of the graph where the graph is increasing, decreasing, or constant. The hardest part, and it's not that hard, is describing where it's happening. Let's start with the first one about the function increasing. Remember, increasing means the graph is going up as you are moving from left to right. So as we move from left to right, are we going up? No. We hit this corner, and now we're going down. But once we reach the origin on this parabola, we begin our journey upwards until we hit the point 3, 9. So this portion, the graph is increasing. Now, how are we going to describe where it's increasing? Remember, the definition says that a function is increasing on an interval on the x-axis. So when we identify the portion of the graph where the function is increasing, we need to ask ourselves, where is this relative to the x-axis? This function starts increasing at 0, and it stops increasing at 3. Because the intervals we use to describe increasing, decreasing, and constant are open intervals with parentheses, we would say that this graph is increasing on the interval 0, 3. Now here's where you have to be incredibly focused. This is an interval, because we're being asked on what interval is the function increasing. These are ordered pairs. They are not describing this number to that number. They are describing a point on the coordinate plane. What about decreasing? Where is this graph decreasing? Again, visually it's pretty easy to see, but just move left to right. From left to right, we're not going down, but once we hit this corner and start heading towards the origin, the graph is decreasing, so I'm just going to put DEC on that portion of the parabola to indicate that it is going down. Remember, you're always moving left to right. Once we hit the origin, it switches to increasing, which we've already decided, but when we hit this peak, this sharp corner, suddenly the graph starts plummeting and resumes decreasing. So where is the graph decreasing? Again, we're looking for intervals of x values. The first portion of the graph, the left portion of the parabola, begins decreasing when x is equal to -2 and ceases to decrease once we hit 0. So one interval on which the graph is decreasing, parentheses, begins at -2, comma, ends at 0. Now, we could put a union here, but I believe in most homework platforms, they would just want you to separate these answers with a comma. The other interval where it is decreasing begins at this peak. So it begins at 3. But when does it stop decreasing? It doesn't. This arrow says, I am going forever in that direction. But does that arrow mean infinity or negative infinity? Remember, we're asking about x's. So in the x direction, this is going forever to the right, and forever to the right is positive infinity. So the other interval on which this function is decreasing is open parentheses, 3, comma, infinity, close parentheses. There's only one portion of the graph we haven't described yet, and that's the first portion, because that portion, being a horizontal line, is where the graph is constant. All of the y values are remaining the same over here. In fact, all of the y values here are 4. So the beginning portion of the graph is constant. So this graph begins being constant at -7 and ends being constant at -2. So what's the interval over which it's constant? -7 to 2. In an open interval, so both have parentheses. And if you're wondering, why didn't I use brackets? Isn't the -7 included? It's included in the domain, but the definition of increasing, decreasing, and constant dictates that you describe it over an open interval with parentheses. So even though this point is included in the domain, we wouldn't say the graph is constant at -7. We say it's constant between -7 and -2. But the real reason we use parentheses and not brackets is actually pretty easy to explain. Look at this point at 3, 9, where the graph peaks. As you are moving from left to right, the moment you're at that peak, would you say you are increasing or decreasing? The minute you hit the top, which is it? Well, it's got to be one or the other. If you're going to say one, then it has to be both. Either you're both increasing and decreasing simultaneously, or you're doing neither. The generally accepted convention is when you are transitioning from decreasing to increasing, or constant to decreasing, or decreasing to increasing, you are doing neither, but you are simply transitioning between the two. If we put a bracket on all of them, then we would have to put a bracket on this 3 and that 3, saying that 3 belongs to the interval where it's increasing, so we're increasing at 3, but at the same time we're decreasing at 3. So either we're doing both or we're doing neither. And the generally accepted convention is you can't do both, so we must be doing neither. That's why we use open intervals, because in transition from one action to the other, you're for the briefest of moments doing neither. You're switching. And that's how you can describe an interval where a graph is increasing, decreasing, or constant.